Good morning, student. This is part 2 of chapter friction. In the previous class, we have discussed the types of friction: static friction, sliding friction, and rolling friction. First, static friction. The force of friction which balances the applied force during the stationary state of a body is called static friction. It is a self-adjusting force of friction. How static friction is self-adjusting force of friction? Let us see this with an activity. We try to push a heavy box by applying a small force, say F unit. The box remains at rest. It does not move. Now increase the applied force to 2F unit. It means that the force is doubled. The box still remains at rest. When an external force acts on the box, the force of friction, known as the static friction, comes into play and opposes the motion of the box. It means motion do not produce in the box. This static friction balances the force which we exert on the box, and the box remains at rest. When the applied force increases to 2F, static friction also increases to 2F and again opposes the motion of the box. This activity shows that force of static friction increases, it means F to 2F, with an increase of the applied force. When applied force double, friction also becomes double. It can increase only to a certain limit. Now we will discuss the limiting force of friction. The maximum value of the static friction when the body is sliding over the horizontal surface is called limiting force of friction. When the applied force increases beyond the limit, it means more than the static friction, the body begins to slide over the surface on which it was resting. Now we will discuss the sliding friction. The force of friction between two objects when one of them is sliding over the surface of other is known as sliding friction. The sliding friction is smaller than the static friction between the two surfaces in contact. When the box starts, when the box starts sliding, the contact point on its surface do not get enough time to lock into the contact point on the floor. So, sliding friction is slightly smaller than the static friction. Simple explanation. Once the motion starts, the contact point on one surface do not get enough time to lock into the contact point of the other surface. Thus, it is easier to keep on moving an object than to start it from rest. This means that more amount of force is applied on an object when it is at rest. If it starts sliding, less amount of force is needed to keep it on moving. Now we will discuss the rolling friction. The force of friction between two objects when one of them is rolling over the surface of other is known as rolling friction. Thus we conclude that static friction is greater than sliding friction and sliding friction is greater than rolling friction. Thus, rolling friction save time and energy to a great extent. The wheel has been considered one of the greatest inventions in the history of mankind. It is much easier to cart a heavy load put on trolley with wheels than to push it. Wheels are used extensively in daily life for transportation. We also see that a small boy carry heavy luggage fitted with a wheel at railway station and airport. This proves that rolling friction saves energy and time. Proper inflated tire roll without sliding. Since rolling friction is less than the sliding friction, therefore there is less dissipation of energy against friction. Hence, proper inflated tire save fuel. Thank you. Have a nice day.